behold the subject, it's very hard to find a well-organized material. Sometimes I need to make the thing by myself, and sometimes I collect all the material and summarize it. And also, this one is one interesting one to explain about the Hadoop distributed file system. It's a comic version. So some of you guys already downloaded and see it. This is one of the best way to explain about the HDFS. So why don't you take a look at this one today? I'm going to use the comic to explain about the Hadoop distributed file system. Okay. So we have the total 6 computer is a server. Okay. So as I said, Hadoop system is on top of existing operating system and existing file system. Okay. Then, even though I do not mention details about each server has their own operating system. Also, each one has their own the Java virtual machine. Okay. Then on top of that, it will have the HDFS, all of the node. This is node. There are 3 different types of node in Hadoop cluster, Hadoop system, Hadoop whatever. Okay? So first one is this is called client. Client is the client server environment. One request the job to the server. So it doesn't have to be the member of the Hadoop cluster. Okay? But usually it can be separate computer or remote machine or some of the computer in your Hadoop system. Okay. Then there are 2 main parts, 2 main groups in the Hadoop cluster, Hadoop system. One is the name node. It's a name node. Okay. It's a name node, it's NN. Okay? Name node is kind of master, okay? Coordinator of your entire Hadoop system. Okay. What is the NN? What is the name node? It's actually process. It's a program. It's a daemon program actually. Daemon program with Java virtual machine. When you install, first you can download the software from Apache Hadoop Foundation. Okay, Apache, the group is the open source project under the Hadoop is the open source project under Apache Foundation. You know the Apache Foundation. Many of you guys are using Apache Web. It's a free software. It's a foundation. They form a group. Okay, they decide whether this will be new component, new project under Apache, the foundation. Hadoop is one of them. So Hadoop foundation is, so that's the reason if you go to the official website of the Hadoop, hadoop.apache.org. Okay, so the Apache foundation. So if you download the software, it will install the same HDFS and MapReduce program. So HDFS is the program for what? File system. It will create the file system. Then when you start up your system, so go back to your relational database model experience. When you start up the EBMS, what happens? EBMS, database Oracle influence, what happens? It creates number of processes, then reserve memory area and link to the file or disk drive where you are going to or where you store the data. It's the same thing. When you start up the Hadoop system, it will create the processes. This is one of the processes in master node. This is a master node. It's kind of the coordinator. Any cluster system, any the parallel system, any distributed system, they have the master node and slave node. So the others are slave node. Okay, this is called data node. So data node. So DN1 we have total. We can have as many as data node. Okay, in this case only 4. But if you have the bigger size of the data, it can be 1,000, it can be 10,000, millions of the node you can have. Okay, so this is a data node and this is a naming node. This is the master node and this is the slave node. So this one, master node, is coordinating entire system, while data node keep data. Okay, so there are 3 groups. So client, name node, and data node. There is another one. Secondary naming node. Can you guess what's the meaning of the secondary naming node? It looks like the backup of the naming node, which is not true. This is not a backup of the naming node. This is just the helper of the naming node. It can be separate module, separate the system. Okay, secondary naming node, or it can be the same node. Okay, but the main job of the secondary naming node is not the backup of the naming node. Instead, is we just say helper. It reduces the overload of the naming node. Okay, it's a housekeeping job. Okay, just manage the raw data or just the check and the data, something like that. So, in other words, if the naming node is failed, the entire system will be failed. So, this is a single point of the failure in the Hadoop system. So, it should be alive while your system is running.
Even if you have secondary? Even if you have secondary nodes?
No. This is not the backup of the. So that's the controversy. Why they make the name of secondary naming node. Okay? So they need to change the name. So don't forget this is not the backup. It's just a housekeeping. So there is a secondary naming node, but this is not the backup of this one. So this is the basic component of the big data system. One more thing. Do you think you can build, do you think you build a Hadoop cluster in one system, which means client, master node, data node?
You can, but it's not.
Yes, you can.
You can, but it's not.
Yeah. Theoretically, there's no problem to build. That is called pseudo cluster. The pseudo cluster is not real cluster because if you are using this one node, okay. So at the time, you can set up create all the process in the one node. So throughout the semester, we are going to use the pseudo cluster for your practice, except administration. For the administration, you will build real cluster with 3 or 4 computers. One of them will be naming node as well as the data node. And the other data node. Or one naming node, 3 data nodes, something like that. Except that most of the exercise lab, you will use one. Your PC with a virtual machine, which is called pseudo cluster. Okay, pseudo cluster is kind of you are pretending the real cluster, but actually that is not the real
I do
cluster.
in one box.
Yes, so in one box, everything. Okay, so that is the Okay. First, we try to write the data. Okay. So client will request to write the data to the naming node. Okay, because naming node is a master node, it's a coordinating every job in your system. So at that time, for example, I had (172 megabyte file). Okay, it's a big file, so okay, not that big. So we have we have 192 megabyte size of the file. Where is it? In the local file system. Local file system means it's not the Hadoop file system, it's not related to file, just on your computer. Okay, even though you are using the same computer for the client and naming node, it doesn't matter. So they are the different file systems. So to utilize the big data system, HDFS, and the map reduced programming, you need to always move. Okay? Copy, sometimes it's called a copy or the move from local file system to HDFS. Through what? The naming node. At that time, if you are using because you are using the multiple computer, they need to communicate. Right? Network. What is the network strategy in the Hadoop system? They are using TCP/IP. Okay? So they are using the TCP/IP, which means it's a socket program. As long as you know IP address and port number, you can communicate. So there is a well reserved port number depending on the purpose. Okay? So we will see details later, but basic idea is so they are communicating each other using TCP/IP protocol. Actually, they can communicate each other through the virtual machine. Java virtual machine has to open the port and receive the data and communicate each other. Okay? Right. So that's the reason. Sometimes you can monitor the Hadoop system using web browser. So it's a nice way to monitor, and even you can see the real data using web browser because they are using TCP/IP protocol. Okay? So the client can request to write the data to naming node. Naming node manage the information about the block. Before they copy the file, the naming node should know which data nodes are available. When they start, so definitely naming node, there are 4 nodes data nodes in our system. But who knows? Sometimes later, one of them will be failed, or network failure, or communication failure. So every 3 seconds, each data node should send heartbeat. Heartbeat. I'm alive. Every 3 seconds, I'm alive. You need to send a message to the naming. That naming node check until 10 minutes. If there is no heartbeat from one of the node, then naming node will consider that node is disabled. Even though server is okay, sometimes who knows the network is a fail. Okay? And something problem. At that time, after 10 minutes, the naming node will consider if until 10 minutes, if there's no heartbeat, information will be considered as the disabled. Then also every 3 seconds, each node should send the heartbeat to the naming node to let the naming node know I'm alive.
3 seconds.
3 seconds, every 3 seconds. Okay. So this is a heartbeat. So which means many node know the D1, D2, D3, and D4. They are alive. Also, many node knows which one is the closest one. Which one is the farthest one? Which means they are sorted the node by distance. How can they decide the distance? If they are in the, most of cluster, they are using red. Okay. If you go to the Professor Boswell's office, there's a Boswell's office, he put the rack in his office, which is not user, but anyway. So it's a rack, so you can put, it's called the LU, it's the size of the height, so you can put a bunch of the computer rack time. Okay? At the time, if they are in the same rack, distance is 0. Okay?
I'm not
Exactly sure. So there's a, you will see in the next PPT slide. But anyway, so in the same rack, its distance is 0, and in the same site, okay, so distance is longer and longer. If they are in the physically different location, its distance is 4, something like that. So they know which one is the closest one based on the distance from naming node to I. So then they sort the DN1, data node 1 is close, data DN2, data node 2 is next, and something like that. Also, it manages the phi. Phi is a 192 megabyte, and based on the block size, we are going to use a 64 megabyte block size. So it's a chop related client level. It's a chop divide the phi by 64 megabyte block size. So if you can change, or you can change the block size when you configure, when you set up your Hadoop system, when you install the first time. Okay? So if you decide to use the 64 megabyte, when client write the file, upload or the move, copy the file from local file. This is a local file system. This is a HDFS. Okay? At the time, client level, the first block 1, block 2, block 3. Okay? But if it has the remainder is 1 byte. Even though you have the 1 byte, 64 megabyte will be allocated. No, actually it allocates 1 megabyte, but it will be considered as the 64 megabyte block. Okay. So first, block 1 is transferred through what? TCP/IP. Okay. Then first block, in naming node, they don't have to copy. Okay? Copy the file, right? Naming node itself is for what? It's a coordinate to manage the entire system. They don't have to keep the data. Instead, they should know all the metadata. So for example, the file name, so let's say this is a full block 1. Okay? So it has the block 1, and also block 1, it should be copied. So at this time, ask the client why the choose available data node is the DN1. So then client will contact the DN1 data node 1 and copy block 1. That is copy. One more important thing is, we learned a lot the cluster system, big data system should support parallel failure, which means What if this node is failed? The data is not available. So which means we need to have the multiple copy. So definitely the header system support the multiple copy. How many copies? 3 copies as a default. So header basically support 3 copies of the data in the same node? No, it's a different node. So naming node actually let client know at least 3 available node. So block 1, data node 1, data node 2, data node 3 in order. That which means it's called the pipelining. Once the data node 1 is starting to copy the data from client to EN1, data node 1, client 1, when client requests copying the first block to the data node 1, they also give the information about the pipeline, which means the second is DN2, the other one is DN3. So, which means once copying is started, DN1 contact the DN2, you should get this data. Okay? So, block 1 will be also copied. Here. And once DN2 is started, this is 1. How many copies? 3. So block 1 has the copy first DN1, DN2, DN3 by order of what? Distance. Okay? It will consider the distance also. Yes.
What is it for the block 1? What does it for?
Block 1 is the block 1 of full. This one?
Yeah.
The full. File full has the block 1. Right now we copy only the block 1. Right? So then, once each data node is completed and informed to the naming node, I'm done. Copy the first block. I'm done. Copy the first block. I'm done. Copy the first block to data node. Then this metadata is completed. Similarly, request the block 2. So we have the block 2. Block 2 is so data node 2, 3, 4. Yes.
Is there any signal to show the name node, the slaves node is successful copying all the
Yes.
blocks?
Once all the block, each block is copied, each node should inform to the naming node. I'm going to copy this block for each node. Yes. So then, finally, naming node confirm this is a copy. So we have 3 copies of the first block of the full file. Okay. Similarly, we can copy block 2, here, block 2. Okay. When they copy, they start from the data node 2, contact the data node, and it's a streaming. Okay? Stream, pipeline. Okay? They do not directly contact the client. Okay. Then, the last one, block 3, E and 3, 4, and E and 1. So, E and 3, E and 3, okay. This is the writing of 5 to HDFS. How many copies? 3 copies. So it doesn't make sense if you have the one data node, right?
Yeah.
Except the pseudo clause. And also, what if we have too many data nodes? Oh, bunch of data node and bunch of file, which means bunch of block information, do you think naming node, one naming node is enough?
No.
As you can see, it's some kind of bottleneck. Right? So you can have multiple naming node, you can say. But in our practice, usually, in general, up to 30 data node, so one naming node is enough. Not the critical. Okay? So you can put
What is the meaning for naming those for? What is the meaning for state nodes for one master node? How many
one master node for, so usually 30, when you have the less than 30 data node, one naming node is enough. Okay? But otherwise, you need to consider multiple copies and distribute it. And that's the reason, as you can see, all of this data will be in the memory for fast process. So actually, each node, even though the Hadoop is cheaper than other the cluster or high performance computing, but you need to have the allowability suggest the 4,000 to 5,000 the PC or computer to implement the Hadoop cluster. Actually, the 4,000 to 5,000 is not very expensive. But for individual, yes, it's a little bit expensive. But for real life system, 4,000 to 5,100 server, it's not very expensive system. Any questions so far?
In the rack also, do we have to add lines and name nodes in the same rack?
Yeah, you can do that. Naming client can be anywhere, actually. Okay?
Anywhere.
Yes. It can be one of the data node, right? It can be. So for example, in client server environment, any client can be any server. And any server can be any client. Something like that. Client can be even in the naming node, it doesn't matter. It can be anywhere. Okay? But if you have a bunch of client requests to the naming node, at that time it can be the load balancing for the client. It depends on your system, overall system architecture. Okay, yes.
This is regarding when we copy data from a client to
The HDF, yes.
Yeah, so what about if we need to retrieve data from the database?
Yes, that's the next step.
Okay, so the last question is, what is the, how we can copy the content, I mean the the addresses of BL1, BL2 to the another or the secondary node, name node. So we're gonna copy all the content table to the secondary or another master node.
No, we do not have another master. Okay? So there's no backup of the naming node, but it is possible to implement the distribute, the naming node. Okay? In case the one naming node is not big enough. So that's one of the problem in the Hadoop computing architecture. Okay? Naming node is a single point of failure, and also it can be bounded.
The client is responsible for the copy the blocks to nodes or just
Client,
copy
no.
to one node?
Client is just for requesting the service. Okay? It's a requesting service to read the data, or to write the data, or to retrieve the data to process it. Just a requesting. Like when you have the client server environment, the web server. Client can be anything.
Right.
Okay? Just like that. Even client can be inside the server. Okay? The same, not very critical or critical.
Excuse me, Professor.
Yes.
You said when I install a Hadoop, I can make the size that we want. Like, is there a standard size for the
What kind of size?
I mean, the blocks.
Block? Yes, 64 megabyte or 128 megabyte.
This is the standard.
Yes.
For the data node, is there any
Yeah, data node is 64 megabyte block size.
for the data node, total data node, one data node has 2 to 3 million blocks.
Yes, definitely one data node has many data blocks.
So is there a size for the data node?
Yeah, but for one file, so right now we have only one file, file, right? So that file is stored at the HDFS. How can we store the file? First, divide by 64 megabyte block. Okay, then have the 3 copies for each block. Okay, then distribute along the different data node. Okay, so to access, I don't start yet how to read the data. Okay, this is the copy, the data. So another thing before we move to the read the data, how can we do that? There is the command, header command. There's a command line, interface command. So you can type, so this is the operating system, your client, the header command, header minus HFS file system and the options. So then we can copy the file. Any other question? So this is the first divide and request to the name node. Okay, there are you need 3 copies of that. So the naming node should know which data nodes are available or sort by the distance. Then give such information to the client. Okay, the client then send the data for the first one, and first one will contact the next one. The next one is contact the third one. That is kind of a pipeline. Okay, that's the main idea.
So the client only contact one node.
Yes.
That's not contact
Yes.
other nodes.
Because one of the requirements of the big data system is minimize the communication. So that's the reason.
Excuse me, Professor.
Yes.
What has been sent in order? I mean, block 1.
Yes.
Which is
In
in
order by the requested, suggest by the naming. Naming node should know which one, which node is available, and what is the distance. Okay.
Excuse me, sir.
Yes.
What do you call these lines? I mean, this is the data and the file. I mean,
This
yeah.
this data in the naming node
So
as a metadata.
metadata.
Yes. So naming node does not have any real data. It has only the metadata. Okay. So we copy, duplicate all the block using the pipeline strategy, and once it's completed, and let the naming node know, then naming node update to such an information. As you can expect, this information will be used for reading a data. Right? So we will see the, how to read the data. All blocks are written and closed. Definitely you need to close the file as you have run in operating system. Okay. So, and I try to read the data from the client. At the time, client does not know what's going on inside the HDFS. So at the time, you need to request to the naming node. I try to read the file full. Okay. Also, you can download the file to the client. Okay. Because they are using different file system. Okay. It's kind of different software. So, just read here. Naming node has the for each block where each block is stored. It's sorted by the distance. Also, and each file has the how many blocks? Block 1, block 2, block 3, and also available data. Okay, then when a client request, so first request to the master node who at the naming node, the info, there are 3 blocks, block 1, block 2, block 3. Then block 1 is located at the data node 1. Doesn't have to contact all the nodes right away, the first one.
Needs.
In case there's no response from this one, it was alive, but who knows? It can be disabled when client contact the data node to download the data. At the time, it can try to the next one and next one by ordering the distance. Because it's already ordered by the distance.
Near first, right?
Yes. Even though it's a little bit slightly different, then short distance, what if you have millions of blocks? Then the total time will be changed. So they consider such a distance. We will see how to decide the distance. Also, you can change the algorithm to decide the distance. For example, we have the gigabit Ethernet here, but this one has the 1000 megabyte speed. This one has gigabit Ethernet. This one is fiber optic. So if you believe, even though the data node 4 is located in other data center, faster, then it can change. Okay, the user can change the strategy. Okay, it's not very critical option, so you can change if you want. Okay. Anyway, so once the download the file can download, what if in the middle of downloading is a stop, then you can actually change into this one. Manually, no. Manually, no. Will watch all the process. If one of the node is slow to provide the service, then they can switch to the next one. That is another benefit of using Hadoop. Okay. Even while you are doing the map-reduce programming later, if one of the nodes is slow, it's not disabled, it's slow, just try the next one. Okay? Which means for the same task, two nodes are competing. If one of them is the finish, the first, then the first one will be applied. Right.
Excuse me.
Yes.
Is there an efficient of the performance? Because it looks like duplicate data, copy. Is that conflict on the effect of the performance?
So why do we need to copy 3 copies?
Just because to if the one
So
was
one
failed-
reason is a backup, right?
Yeah.
Backward. And another one is we are going to use when we process the job. It's called the locality. So we are going to sum the salary. Yes, the salary information are in this file. Then at the time we can process block 1. Okay, sum salary in block 1. And this node sum salary block 2. And sum salary block 3. Then later we will combine. So that is another reason to parallelize. So to make the parallelism, we will divide the file by the block. Okay?
Combine.
Then later we will combine. That is actually called map and reduce. And during the map, it's based on locality. Okay? It's a process only for local. Okay? So we will see details about that, the locality programming in the map reduce next week. Yes.
If name noding assign data into to be the first one to connect with the other nodes.
Yes.
So if we have the DN1 alive again, so it's gonna be take the connection again, or it's gonna be the second.
Oh yes, because for example, the DN1 is failed to send the heartbeat.
Yeah.
So the main node consider this is not available, so all DN1 will be disabled over here, right? Okay. And naming node will give the information about this block 1 for DN2, so you can access the block 1 from the DN2 and something like that. Later, if DN1 is alive, going back, so one network is recovered, then once the name node receives the heartbeat, it will be available, then all data node will be available. Okay? Without the restart the system. So that's another benefit of using the Hadoop. Okay. So this is the read the data. Okay, at the time, the client requests to read. Read means download the data from HDFS to the local file system. Don't be confused. The HDFS is another data file system. Okay, so I prefer to give the operating system project to implement file system. Then many of the students actually got confused. How can I build a file system? You can build a file system. What is a file system? It's a group of software for what? Manage the file. So if you have for example, Windows file system is FAT32 NTFS, it's another file system. On top of that, you can implement another file system. This is one. Okay? So when you install the HDFS header, it will install another file system on top of the existing file system.
File system for Hadoop.
Yes, file system for Hadoop. So that's the reason you need to upload the file, download the file. If you want to use the MapReduce programming, you need to upload the file to HDFS, even though you have the file in your local machine. It doesn't make sense to use the local file system for MapReduce. You cannot get such a benefit. Also, if you want to see the entire file, okay, I want to list up and edit the file. At the time, you cannot edit. So why? This one is for write once and read maybe only once. Right? Okay, kind of read only data. Why? Why is a read only data?
Read only?
Yes, it's a read only. So write once, then read many times. What about your file system on your operating system? You can modify whenever you want. And read. Are you gamers? Yes.
Can you delete these files?
You can delete the file, then be create. But suppose that you have the 1 petabyte size the file. Takes some
I
time.
think you cannot read because the blocks are fixed. You broke 3
The
blocks.
reason is that this is Hadoop is not for online transaction already. Okay? If you want to search an online transaction processing, you'd better use relational model, relational DBMS. So, as I keep saying, Hadoop has a specific purpose. It's not general solution. Definitely not. Even MapReduce, everybody, many students, many researchers has the expectation of using the MapReduce programming. It can help the project or my research to speed up. Why? Everybody says the MapReduce programming is fast. Not all the algorithms fit to the MapReduce. You will see why. Okay? The simple idea is find maximum. Maximum, you can select the maximum from here, maximum from here, maximum from here, and 3 maximum you can select the highest value. And it works. MapReduce is working very well. But what if not associating the algorithm, which means you need to consider some other data, each other. Okay? To decide the highest value, you need to access another file. Okay? Then their output value is not the correct value. We will see the example later. Okay? So this is the reading of data from HDFS. Okay? So download the data from, at this time, client can directly contact the data node and download the data to local file system. So the next part will explain about how to support the fault tolerance in the HDFS. Okay. So first thing, basically, the data node will send the heartbeat to the name node from time to time, every 3 seconds. Okay, also the naming node will keep checking whether data nodes are available or not. So if there's no heartbeat for maximum 10 minutes, it will be considered as a disabled. Okay, that is the node failure. Okay. Once it is going back, it will send the heartbeat, then the naming node will consider as recovered available. And also, for the network failure, probably you learned about shaking hand during the network communication. So every time you send the data, it will send back the acknowledgement. So which means they confirm they received the data. Also, what if the data packet itself, they are using the, I remember exact, probably it's a 64, right? This is a packet size. This is different from the block size. This is a packet size when you transfer the data. Okay, it's a network packet size. So I think the 64 byte somewhere here. But anyway, so this is the packet size. And each packet has a checksum. So using the checksum, you can verify whether data is corrupted or not. It will be possible part of the data will be corrupted or loose. Then how can you make sure whether data is okay or not? At the time you can check. You can use the checksum data. Basically, it's for example, the sum of the if you have 1, 2, 3. So checksum is always the sum of this one should be 10. Okay? So your checksum is 7. So 1 plus 1 plus 1 plus 7 is 10. What if this one is corrupted? Then you will have only the 9. So this is corrupted. But this approach is used for what? Antivirus program. Okay? It's a basic idea whether the file is the modified or not. Okay, so we already discussed. Whenever you write the data node should send back the acknowledgement, not only for the data block writing or the communication in the header, it's based on the request and the acknowledgement. Okay. So when you request to read the data, it will return log 1 data node 1, 2, 3. And return first contact the data 1. If data 1 do not return the acknowledgement or do not send back the data packet, then you can contact this one. You need to do the manually? No, you don't have to. Your header system will take care of such a thing. So this kind of information are in the metadata. Another thing I do not mention is data node 1 as block 1 and block 3 and so on. So all metadata you need will be managed in the data name. What if this node is failed, physically failed? So you can add while the whole entire system is running, you can actually replace the day 1 of the data node. That's possible. Okay, non-stop, the supporting. And once you replace this one, naming node has the information about the data node 2. Data node 2 should have the block 1 and block 2. But this one is marked disabled because of failure. Once it's rejoined to the cluster, you have the information about this one and ask data node to get the block 1 information from nearest. Okay, nearest one is this one and copy. And block 2, so nearest one is data node 3 and copy. And finally, it will be unknown. That's the basic idea how to reviewing to the cluster. So I do not who will see the details the slide for the rack and the data node. So but the headed system will consider distance. Physical distance is for the D0 to D6 or 8. If they are in the same leg, it's called the 0, and the next leg is 1, and something like we will see. And also, they do not, in case you manage the rack, they do not copy more than 2 in the same rack. Why? If they are in the same rack, and block 1 are in the same rack, what if entire rack is the fail? That will be possible. Physically, somebody unblock the rack, the power, so they do not put all 3 blocks in the same rack. The maximum 2 replica in the rack.